Hello students, once again welcome back to my channel. In this video, I will share with you some sums of trigonometry. So let's get started. So before I start with the sums, let us revise some formulae which I have already discussed with you in the previous videos. In this right angle triangle ABC, where B is right angled, that is it is 90 degree. So for we consider angle A, which is considered as theta here. So in this right angle triangle, where angle B is 90 degree, BC is the perpendicular, AC is the hypotenuse, and AB is the base. So sine A will be perpendicular by hypotenuse. Perpendicular is also written as opposite side by hypotenuse. Cos A is base by hypotenuse, and base is also written as adjacent side. So adjacent side by hypotenuse. Tan A is perpendicular by base, that is opposite side by adjacent side. Cot A is the inverse of tan A, so it is base by perpendicular, so adjacent side by opposite side. Sec A is the inverse of cos A, hypotenuse by base or hypotenuse by adjacent side. Cosec A is the inverse of sin A, hypotenuse by perpendicular or hypotenuse by perpendicular is also written as opposite side. You can see the previous videos of trigonometry where I have discussed with you in details these formulae. Now coming to sine theta is 1 by cosec theta, and cosec theta is also written as 1 by sine theta. Cos theta is 1 by sec theta, or sec theta is written as 1 by cos theta. That is there the inverse. Tan theta is 1 by cot theta, or cot theta is 1 by tan theta. Tan theta is given by sine theta by cos theta. So you have to remember these important formulae. Cot theta is cos theta by sine theta. And you also have to remember sine square theta plus cos square theta equals to 1. Tan square theta plus 1 equals to sec square theta. It is also written as sec square theta minus tan square theta. If we take tan square theta on the right hand side, so sec square theta minus tan square theta equals to 1. And 1 plus cos square theta equals to cosec square theta. It is also written as in some books cosec square theta minus cos square theta, because we take cos square theta on the right hand side. That is, we take cot square theta on the right hand side. So we get cosec square theta minus cos square theta equals to 1. Again I repeat, sin square theta plus cos square theta equals to 1. Tan square theta plus 1 equals to sec square theta. 1 plus cot square theta, this is not cos, remember. 1 plus cot square theta equals to cosec square theta. Now let us start with sum 1 after we have revised all the formulae. So here it is, we have to prove sec A minus 1 divided by sec A plus 1 equals to 1 minus cos A divided by 1 plus cos A. So we have to prove left hand side equals to right hand side. So let us start with left hand side. Sec A minus 1 divided by sec A plus 1. So we know sec A is written as 1 by cos A. So we write sec A is 1 by cos A. And sec A here, similarly in the denominator we write 1 by cos A plus 1. Now we take the LCM here, cos A is the LCM. So we get 1 minus cos A divided by cos A. Similarly in the denominator we take cos A as the LCM. We get 1 plus cos A, because here we don't have anything. So 1 plus cos A divided by cos A. Cos A gets cancelled out. So what is remaining? 1 minus cos A divided by 1 plus cos A, which is equals to right hand side. Right? So this is how we have proved left hand side equals to right hand side. Now moving on to sum 2, we can see we have to prove 1 minus tan A whole square plus 1 plus tan A whole square equals to 2 sec square A. So let us start. So first we solve the left hand side. So here we see 1 minus tan A whole square. We use the formula A minus B whole square. So 1 plus tan square A minus 2 tan A. That is A plus B whole square, A square plus B square minus 2AB. Here A is 1, right? Similarly, we use the formula A plus B whole square. So 1 square plus tan square A plus 2 tan A, because A is 1 here and B is tan A, right? So what do we see? Plus 2 tan A and minus 2 tan A gets cancelled out. This one and this one gets cancelled out. So what is remaining? 1 plus 1 is 2. 2 plus 2 tan square A. Here tan square A, tan square A. So here we take 2 common. So we get 1 plus tan square A. So we know 1 plus tan square A is sec square A, because we know sec square theta minus tan square theta equals to 1. So 1 plus tan square A will be sec square A. So this is how we have proved equals to right hand side. Now moving on to sum 3. Tan A equals to sin A by square root of 1 minus sin square A. So let us start with right hand side here. We know sin square A plus cos square A equals to 1, right? So we can write cos square A equals to 1 minus sin square A, because we take sin square A on the right hand side. So if we take the square root, we get this one. Square root is cos A, right? So cos A equals to square root of 1 minus sin square A, right? If we take the square root, we get cos A equals to 1 minus sin square A square root. So instead of this thing, we have written cos A, right? The numerator remains the same. Here I have shown you the how I have found cos A, because cos square A equals to 1 minus sin square A. So if we take the square root on both the sides, so cos A equals to square root of 1 minus sin square A. So cos A equals to 1 minus sin square A square root. Right? So sin A by cos A is what? Tan A. So we have proved right hand side equals to left hand side. Here we have started with the right hand side. Now moving on to sum 4. Here we have to put sin to the power 4A plus sin square A cos square A equals to sin square A. So here you can see that we can take sin square A common, right? So we take sin square A common. So what is remaining here? Sin square A. And what is remaining here? Cos square A. So we know sin square A plus cos square A equals to 1. So we get sin square A multiplied with 1 is sin square A, which is equals to right hand side. So proved. Now moving on to sum 5. Sin A multiplied with tan A divided by 1 minus cos A equals to 1 plus sec A. So let us start. Here we write tan A as sin A by cos A, right? Tan A is written as sin A by cos A, and this 1 minus cos A remains as it is. Now sin A multiplied with sin A, we get sin square A, and this cos A comes in the denominator. So we write this as cos A multiplied with 1 minus cos A, because this is in the denominator, right? This is a continuation. Now sin square A is written as 1 minus cos square A. See, in the last step, what we have seen, sin square A was in the numerator. So sin square A is written as 1 minus cos square A, because we know sin square A plus cos square A equals to 1. And the denominator remains as it is. Now 1 minus cos square A, we know A square minus B square is equals to A plus B and A minus B. So here A is 1 and B is cos A. So A plus B, that is 1 plus cos A, and A minus B, 1 minus cos A. And the denominator remains the same. Now if you can see 1 minus cos A, 1 minus cos A gets cancelled out. So we get 1 plus cos A, which is remaining in the numerator, divided by cos A. So this is what we are supposed to prove. Now 1 by cos A, now we split it. 1 by cos A plus cos A by cos A is what? 1. So 1 by cos A plus 1. Now we know 1 by cos A is what? Sec A. So we get 1 plus sec A. 1 remains as it is. 1 by cos A is sec A. So this is equals to right hand side. Thank you for watching my video. If you like my video, do subscribe and don't forget to press the bell icon. Bye bye. Have a great time.